Okay, so got these expressions to factor. And the hint is, at least on the first one, you got to find a number to put here and a number to put here with a plus or minus in each case as needed, in order that when you multiply it out, you get this. Okay, so let's say you got x squared minus 5x minus 36. Well, as I've explained in previous classes, you could try every possible combination. I mean, you could do x minus 36 times x plus 1. That would give you minus 36. Then it would give you minus 36x plus x, which is minus 35x. You're not going to get a minus 5x out of that. Okay? So that doesn't work. Then you try maybe smaller numbers. Let's say x minus 3 times x plus 12. Well, we're getting closer. Negative 3 times 12 is still 36. Of course, then you're going to have a 12x here and a negative 3x here, which gives you a plus 9x. And plus 9x isn't very helpful because this is minus. Of course, if you change the signs here, then you get a plus, you get a minus, and you get x squared minus 9x. Plus 36. Well, that doesn't help much. Let's try x plus 4 times x minus 9. Okay. Well, that's going to give you 4x and a negative 9x. That's a negative 5x, isn't it? If you multiply that out, that does equal. Let's do the whole thing, x times x minus 9 plus 4 times x minus 9. That equals x squared minus 9x plus 4x minus 36. And lo and behold, you get x squared minus 5x minus 36. Okay. Now, what we did before was I just listed all possibilities for 36. So I could use minus 36 and plus 1. I could use x plus 36 and x minus 1, but I wouldn't do that because I know that's not going to give me a negative on x. Okay? And 36 and 1 is never going to combine to give me 5. So I've got to find two factors of 36 that'll give me a 5 when I am. Okay? So I could try 2 and 18. Well, that's never going to add up to 5, no matter what my signs are. I could try 3 and 12. We're getting closer. We at least get like a negative 9x, which is get kind of close to negative 5x, but it isn't negative 5x. So then we try a 4. This 4 goes into 36. 4 and negative 9 gives us negative 36. And 4x and negative 9x gives us a negative 5x, and we've got it. So that's how you think about it. Well, last time we listed every possible combination. We're going to do a lot of that today too, because we're going to talk about when you don't have a 1 in front of x squared. And that gets a little more complicated. Okay, but that's the process. So we can use that process for this one now. We got x cubed. Now, not all others knew they were close. They held out an historical commission continued to team up and searching the National Geographic Society, Smithsonian Institution, and the Slavery. Looks like that's a history video from the 1950s, which is current events to me. Okay. Now you got this. Okay. First, we factor out x. We notice that x is a common factor. Of course, having done the assignment on factoring monomials, that'll be familiar to you, okay? Factor out the biggest possible monomial before you do anything else. Okay, and then that gives us x squared minus 2x minus 3. And x squared minus 2x minus 3. The only factors you can have are 1 and 3, right? So we could try x and something, x and something. We could try x and 3, x and 1. The question is just where to put the plus and minus sign. Well, we need a negative 2x. We better have the negative in front of 3. That means we have to have a positive in front of 1 because these have to multiply out to this. Then when we do the distributive law, we're going to find that this gives us a negative 3x and a 1x, which is a negative 2x. We still have to have that x there. Okay, we don't want to leave that out because if you just multiply this out, you don't get this. Okay, so make sure when you multiply it out, you get what you started with. And as I always say, check. Do the multiplication. Forget what you started with, do the multiplication, see if you end up with this. That gives you immediate feedback on whether you did it right or not. Okay, now. And this is, I thought this was pretty neat when I first saw it. It took a few minutes. Well, it took doing an assignment to get really used to it. Okay. And then it gets kind of locked in. Okay. So this is not in the form x squared with something times x plus something, right? It's not in this form because you got that x to the fourth in it. You can't factor anything out like you did here. So what are you going to do? Well, I say let, I don't know what symbol Open Math tells you to use. Let u equal x squared. Then x squared plus 5x squared plus 6 becomes x to the fourth. Becomes u squared plus 5u plus 6. And that factors as u plus 3 times u plus 2. And check that out. You gotta get 3 times 2 is 6, 3u and 2u is 5u, and u times u is u squared, so that works. Now, actually, I didn't need to erase that. Okay, which represents x squared plus 3 multiplied by x squared plus 2. Now you check. You get x squared times x squared plus 2 plus 3 times x squared plus 2 equals x squared times x squared is x to the fourth. X squared times 2 is 2x squared. 3 times x squared is 3x squared. And 3 times 2 is 6. And this equals x to the fourth plus 5x squared plus 6. And look at that, there it is. And there it is, okay? So what your trick is, I'm gonna just kind of summarize it over here. Never do want to write that fourth there, okay? If u equals this, then this represents this. U squared plus 5x plus 6 is this, which represents u squared x squared plus 2 times x squared plus 3. Which is equal to our original. Not going into all the details. That's our reasoning. I do recommend when you do these problems, you learn a lot faster if you write out my words. Nobody ever does. Everybody's in a hurry, takes shortcuts. And maybe learns it better that way. You got your own way of organizing your thoughts. And that's okay. But do something besides just be satisfied when you get the answer. Okay? Think back on the process, make sure you're learning the process. Good heavens. Wonder what it was in my pocket. Okay. There's an obnoxious rose bush my way this morning. Then I just slipped those in my pocket after I trimmed it back. Okay. That was a long time before I left the house. I wouldn't have bothered to do that unless my way was being blocked at the last minute. But okay, there we have it. Now, I'm going to turn to the idea of factoring trinomials when you don't have that convenient one in front of x squared. Of course, it isn't in front of x squared because you don't write it, but you understand what I mean. Okay. Make sure something right, isn't it? Yeah, got everything. Okay. If I multiply this, what I get is 6x squared. Then I've got 4x and I've got 15x. That's 19x plus 10. Now pretend that you don't know that this comes from this expression. And it's gone. How do we rediscover the expression that just disappeared? Well, we know That's inconvenient. There are other ways to hold the chocolates if this works. And my writing will probably deteriorate a little bit. Because I had to move the chalk on the other side of that knuckle. There's something in that knuckle. Doesn't want to hold the chalk. Eventually your body wears out. Okay, so you have something in front of X plus something else multiplied by something in front of X plus something else. What could these numbers be? Well, this number here could be 2. And if it is, then this number is 3, right? Because the number in front of X and the other number in front of X have to multiply out and give you 6. Make sense? Okay. Now, what are 2 numbers I could put here? Just hold up fingers. Somebody tell me one of the numbers I could use here. Remember, what do these 2 numbers have to do? They have to multiply out and give you 10, don't they? Okay, so 5 could be one of the numbers. Okay, so if 5 is one of the numbers, then 2 is the other. Okay. Where are my the 2 and the 3 give us the 6. Because 2x and times 3x gives us 6x squared. The 5 and the 2 give us the 10. Right? So that's one possibility. Let's test it. Okay, so that would be 2x plus 5 times 3x plus 2. Now, if we're very lucky, we're going to get the result. And actually, turns out that we're lucky. This one's going to work. Okay, so just to write it out, 2x plus 5 times 3x plus 2 equals I'm tempted to shortcut it about 3x plus 2 times plus 5 times 3x times 2, which equals 6x squared plus 4x plus 15x plus 10, which equals 6x squared plus 19x plus 10. So we just happened to stumble on the right possibility here. Okay. Now I could have chose other possibilities. I could have put a 1 here and a 6 here, couldn't I? There's a 1x and a 6x multiplied is going to give me 6x squared. I could have put the 2 here and the 5 here. Okay. It wouldn't have worked. So we've got to understand that there are a lot of possibilities here. And when you're first doing these, you're probably going to have to try a lot of different options. Okay. So if we start with I'll just list the possibilities. Could be x plus 1 times 6x plus 10. Could have been x plus 10 times 6x plus 1. In each case, we get a 6x squared and we get a 10, right? But we don't get the 19x. It's figuring out what it takes to get that 19x. Okay. Or it could have been x plus 2 times 6x plus 5. Or it could have been x plus 5 times 6x plus 2. All of these give you different results. Okay. Now it's none of those, but if you don't know, you might have to try all these. When I look at these though, I can tell pretty quickly that, well, I mean, this one comes fairly close to working. I get a 6x here, and x times 10 is a 10x, that's 16x. That's kind of close to 19x. I'm not that far off. If I multiply this one out, I've got a 60x here. So I'm probably not even going to, when I think about that, I might not even write it down, or I might write it down and immediately cross it out. That's no way that's going to work. Okay. Well, now this one gives me a 12x and a 5x, which is 17x. We're getting awful close to 19x, right? But we're not actually getting it. And this is going to give us a 30x and a 2. 30 and 2 is not going to combine to give us 19. But these two are kind of close to possibilities. Okay. Or we could then try 2x here and 3x here. So it could be then plus 1 plus 10 or 2x plus 10 times x plus 1. And maybe we, yeah, 3x plus 1. And maybe we don't bother writing that down because 10 times 3 is 30. And that's going to be too big. Okay. Nothing we get here is going to reduce that 30 to 19. Okay. And we have 2x plus 2 times 3x plus 1. Or 2x plus 3 times 3x, and it's not plus 1. It's 5. Okay. Well, right there are pretty much all the possibilities if we're going to factor this over the integers. In other words, I'm going to get whole numbers here, integers with the coefficients. And all the numbers here are whole numbers or integers. Whole numbers would be positive. Integers could be positive or negative. Okay. There are 8 possibilities. And out of hand, we could dismiss this one. We could dismiss this one. We could dismiss this one. But we wouldn't be wise to dismiss any of the others. They're not obviously going to give us something that's a whole lot different than 19. Okay. So if we did it like this, how many of these things would we have to test before we arrived at this one? Well, that's here, near the bottom of the list. Oh, sorry. It is at the bottom of the list. Okay. If we do these kind of in numerical order, that's a logical numerical order that I use. You don't know where you're going to hit it. You don't even know if you're going to hit it. Okay. So what I'm going to do now, I'm going to do, I'll just stick with 2 and 3 here. We'll get too many factors. Keep this kind of easy. This equals 6x squared. That's going to be minus 12x plus 4x. That's minus 8x minus 8. Okay. Now, what are you going to do with that? If you don't know what it started with? Well, you're going to make a list like this. So go ahead and just make a list. See if you can do it in an organized fashion that makes sense to you. It covers every possibility. Okay, so I would recommend, first place, let me just observe, because one of you saw, whoa, we'll factor 2 out of this. It does make it simpler, okay? But if this had been, well, odd numbers that I could have put here, and then you wouldn't have been able to factor the 2. Anyhow. I'm going to do the possibilities for x here and 6x here. What are the possibilities? Well, first place, I could do x minus 1 and 6x plus 8. Or I could do x plus 1 and 6x minus 8. So what I'm doing is I'm using 1 and 6 and 1 and 8. Okay? And they're just 2 possibilities, but the 1 and 6, I mean, factors, the coefficients of x would be 1 and 6, and I'm going to keep it that way until I've listed all the possibilities with a 1 here and a 6 here. Okay? So I'm going to keep x here. I'm going to keep 6x here. Okay. Other ways of getting 8 would be minus 2 plus 4, or minus 4 and plus 2. These would be possibilities. Okay. Or, well, that's it. Okay. In other words, 8 can be represented as 1 times 8 or 2 times 4, and that's it. And I didn't need that. I was thinking something different. Okay. That's all we can do with a 1 in front of x and a 6 in front of the other x. Then we'll do 2x, 3x. Again, we go with minus 1 plus 8. Minus 1 here. And we've got 4 more possibilities. Now, are there any possibilities that we haven't considered? Okay, so far there are 8 possibilities, but there are others. How about x plus 8, 6x minus 1? List that over here. Okay. Or x minus 8. And 6x plus 1. Or x plus 4, 6x minus 2. These are the same numbers I have here. Just putting the 4 and the 2 or the 8 and the 1 on the opposite side. Or now there are a lot of ways I could get these 4 possibilities. But basically what I'm doing is I'm reversing these 2 numbers in each of these. Okay. And other possibilities, same thing down here. I can do 2x plus 8 times 3x minus 1. 2x minus 8 times 3x plus 1. 2x minus 4 times 3x plus 2. 2x plus 2 times 3x minus 4. In all of these cases, I get my minus 8 and I get my 6x squared. If you can list all possible cases, which is kind of tough to do, you can then test them. I'm going to have here a minus 6x and a plus 8x. Well, that's not going to give me a minus 8x. And a 6x and a minus 8x doesn't give me 8x. And a negative 12x and a 4x. Uh-oh. Look there, I hit it. If I multiply this out, I definitely get my minus 8 there. I definitely get my 6x squared. And I get minus 12x and 4x. Minus 12 and 4 is minus 8, gives me minus 8x. So I can say, yeah, that works. What you need to understand is, for any one of these things, there are a huge number of possibilities. Not a huge number, but you list them on half a page. Unless I get really mean and give you a number like 36 out here and 54 out here. Okay, because 54 has lots of factors and 36 has lots of factors. Take you full page to list those, unless you write really small. Okay. Okay. Now, I'm going to sneak the right one out to make sure I got it round on. I know how to do this. So. Keep the number small. I can do this in my head. My head isn't working. Oh, that sheet. So that's going to give me. Those are all even again. Now, without factoring the two out, because you do factor the two out of this, it gets a little bit simpler. Okay. You have fewer possibilities. See what you can do with this. And let me double check it to make sure. See, I've got 324. 36. Because I have the right number. Okay. Should be 12. Yeah, that works. Okay, so you've listed possibilities. Now, turns out that there's a shortcut, which you ought to be ready to appreciate. I do want you to understand, how to list things systematically. It's just a good skill. And it gives you a context that makes you appreciate the shortcut. Okay, so I'm going to take this number and multiply them, I get 72. Now, how many ways can I express 72 as a product of two numbers? Okay, well, could be 8 times 9, 6 times 12, 3 times 24, 2 times 36, 1 times 72, right? A lot of ways to write 72 is a product of two integers. Eight plus 9 is 17. 6 plus 12 is 18. 3 plus 24 is 27, and we can go on. Okay. What we're looking for is 18. There it is. Now, if we write hold on, I'm getting messed up here. Let me stop for a second. Okay, sorry, got it. It's thinking too hard. You got 12x squared plus 6x plus 12x plus 6. I can write this. No, that's not going to work. Sorry, just had a little brain freeze here. Okay, now I take these terms here, and I can multiply, I can express this as 6 times 2x squared plus 1 plus 6 times 12x plus 6 times 2x plus 1. Okay? Make sense? Well, let's see if you follow. I'll explain it a little more thoroughly in a minute. I want to give you a demonstration. Okay. There should be 6x times 2x plus 1. So now I can write this as 6x plus 6 times 2x plus 1. And there's my factor. 6 times 2x is 12x. 6x times 1 is 18x. And 6x times 2x gives you the 12x squared. 6 times 1 gives you the 6. Okay. So let's look at, let's find a piece of unused board. Let's try 6x squared plus 19x plus 10. Now multiply these two numbers. Okay, well, you get 6 times 10 equals 60. Okay. Now 60 could be 1 times 60, or 2 times 30, or continue it. Write out all the ways you could write 60 as a product of two numbers. Okay, well, 3 times 20, 4 times 15, 5 times 12, 6 times 10. Okay. Now 7, 8, and 9 don't go into it. And the next number you divide by would be 10, but you've already got 6 times 10, so you don't bother. They'll say, you could go down to 10 times 6, but there's no need to do that. We just kind of cross that out. Now, can you give me one of these where the numbers add up to 19? Can you pick that one out? Well, here. Okay. 14, 15 add up to 19. 4, 15. So we write okay. Make sure I have the right numbers in the right place. We write this. We have the 6x squared. That's what we write here. This number This expression goes here. And then the number you got on the end goes here. And then these two numbers go here and here. Doesn't matter which one you put where, we'll see that in a second. Then you factor. Factor out a 2 here. Factor out a 5 here. And factor out the whole 2x here. And what do you get? Must have woke up on the wrong side, awakened on the wrong side of the bed this morning. But do it again. If I factor out of this group, okay, factor this, I can factor 2x out of this. It gives me 3x plus 2. And then over here, I factor out 5, and I get 3x plus 2. So the way this works out, I've got a 3x plus 2 here and a 3x plus 2 here. If you follow this method correctly, you're always going to end up with the same thing here as you got here. Then we just use distributive law in reverse and say, well, that's got to be 2x plus 5 times 3x plus 2. Okay? That makes sense? Okay, now, if you look at what we did over here, we just happened to list the right thing first, which is 2x plus 5 times 3x plus 2. Then it multiplied out to this, which is where I got this expression. Okay? Now your book will explain that method, but you see the pattern? Kind of. Okay. Multiply the coefficients here, the 6 and the 10, and write that as product of two numbers in every possible way. I would start divide by 1, divide by 2, divide by 3, divide by 4, divide by 5, divide by 6, and that all works. If you try to divide by 7, it doesn't come out even. Divide by 8, it doesn't come out even, get 7.5. Divide by 9, it doesn't come out even, you get 6 4/9. Okay. And then the next number to divide by would be 10, but you've already got 10 here. So you get 10 and 6, but that's the same as 6 and 10. Then you pick out if one of these, well, you try to find one of these, see if one of these adds up to this number. Okay, so there's where this number comes in. Then you write this number here, and then put one of these numbers in front of x and the other number in front of x, but write them separately. And take these two and factor out whichever you can, if there's something you can factor out. And take these two and factor if possible. Then use a distributive law. That's an algorithm. You're probably not going to understand why that works. Okay. But that's similar to an algorithm you saw for factoring a trinomial with a 1 in front of x squared. If you look at the way open math explains it. Okay. So if you've done the assignment you do today, yeah, I think that was due today. You know, let me look at that. Make sure that I've got the Yeah. So the next section, do these kinds of trinomials and do next time. Okay.